USB Rubber Ducky is this little thing made by Hack5. That's basically like a keystroke injector. You like program a little payload like this, for example, in this little picture here. And then when you plug it in, it runs all those commands in like a matter of seconds. You can run like PowerShell, you can type out entire scripts and things. You can do a lot of really crazy things with rubber duckies. And they've been featured on like TV shows and movies, like it was in Mr. Robot, which is a fantastic show that anyone who's interested in hacking and security stuff should definitely watch. I already have one of the actual rubber duckies right here, but I'm going to make one of these, which cost about $45, and I'm going to make my own one with one of these, which is a Raspberry Pi Pico that cost about $4. I'm going to be coding it in CircuitPython. There's like a whole little kind of scripting language that payloads use, and then you need to translate that into actual like key codes as if you're typing it with a keyboard. There are a bunch of like libraries that Adafruit has built for CircuitPython. You can download all of them. There are a bunch of them that make a lot of functions much easier. The Adafruit HID library has all kinds of built-in functions about how to interact and function as different kind of HID devices. And if you don't know what an HID device is, I forget what it stands for. It's like human interface device. I think it's, yeah, that sounds right. Human interface device. So that's HID is just like a catch-all for all the things that humans use to interact with a computer. So keyboard, mouse. I'm pretty sure like a USB like PlayStation controller would be considered an HID, stuff like that. So we are going to need that Adafruit HID library in order to act as a keyboard, which is what we need if we want to act like a rubber ducky. Because a rubber ducky is posing as a keyboard, and we are going to pose as a rubber ducky, which poses as a keyboard. So by the transitive property, we have to pose as a keyboard. So we need that Adafruit HID library. So we can get this from this GitHub page, which has, you can download the entire bundle of all of their different libraries. So this bundle right here will come as a zip file, and you can download that whole thing, and it will have a bunch of different things in it. It has like examples of how to use some of them in here, but all of the actual libraries that you'll use is in the lib directory, and you can see all of the different libraries that they have built for this kind of stuff. But the one we are interested in is going to be this Adafruit HID. So what we're going to do is we're going to copy that entire folder and move it to the /lib folder on our Raspberry Pi Pico. And if we had plenty of storage space, we could just move this entire directory with all of these different libraries onto our device that we're going to use. But the hard drive space is pretty limited on the Raspberry Pi Pico. It's just like onboard hardware. There's no SD card or any sort of extra storage on it. So just to save storage, we're going to only transfer the libraries that we need. So I'm just going to take this Adafruit HID library. I'm going to copy it, go to our CircuitPython directory, go to the lib directory, paste, and it will copy it over. And now we have that Adafruit HID library available for our device. So we can go ahead and we can import all three of these, because we're going to need all of these. We're going to need the keyboard layout, we're going to need the keyboard itself, and we're going to need key codes. I am going to try to add this safety. So this is going to require using the GPIO pins. So like all of these things along the sides, like those are all, they're called like pins. Technically they're not pins because they're holes in them that I could add pins to. Like I have some loose pins that I could mount right there, but I could also just like solder wires directly to it. That's probably what I'm going to do. My plan is I want to have, I'll do another shitty MS Paint diagram. If button pressed, don't run code. That's kind of my plan. I'm going to do the black wire to pin 17, which is the GP13. I'm going to do the red wire to pin 36, which is the 3D3. If I plug this in, I should be able to press this button and it should print out down here, button pressed, and the little LED right here should light up as well. I'm going to plug it in and I hope nothing blows up. Let's see if I run that. Button not pressed. Now I want to hold down the button, run it again. Button pressed. Did it turn on the, I wasn't watching, did it turn on the LED? It did, it blinked very briefly. Awesome. Okay, so the button is working. If button pressed, blink LED 5 times. If button not pressed, run Ducky script. I'm holding down the button, plugging it in again. There we go. It's blinking the LED and it's not running the payload. And if I let go of the button, it's still blinking the LED and not running the payload. Awesome. Now I unplug it. I am not pressing the button this time. And I plug it back in. And now it runs the payload. All right, I think our little like safety button is done, at least from a functionality standpoint. I printed this little case, and my plan is, so the Raspberry Pi Pico should sit inside here. The USB port will stick through there, and then I'm going to place this. It's just like a little snap-in. It doesn't require any screws or anything. It snaps in on top of it, and I want to super glue this button on top of this. I'm gonna have to undo this soldering on the button which is a very sloppy soldering job anyway. I'm not that great at soldering. Everything I know about soldering I've learned just trial and error and hoping not to burn the house down. I'm going to remove the soldering and like unhook this button and then put it into the case and then put the button back together and then super glue the button, or I'll super glue the button on top of the case first and then I will solder the button back together. First things first, I just need to undo the soldering on this button. So the button is removed. If I want to put this inside the case, that fits pretty nicely, I think. Yeah, that's pretty snug in there. That's not falling out unless you pull it. Yeah, that seems pretty good. And now this is gonna go on top of it. I think I want it in the middle, and it fits pretty well if you go over 2 of those little slats or ridges or gaps or whatever you want to call them. I think like that is pretty good because I'd imagine that it's like I'd be like plugging it in like this, and then my thumb would just be on the button and like I would press it and plug it in. Something like that. But I'm gonna let that sit for a bit just to make sure that it dries and it's holding before I start soldering the wires to it again. In the meantime, I can be like trimming these wires again just to get an idea of like how far it needs to go. Having a little slack is fine. I just don't want to be like stuffing a ton of wire into the case that I don't need to. I'm thinking like here. That seems good. Right there. Yeah. Seems like a pretty good length. And now I need to strip the end of the wire. Strip the end of that wire. I may have stripped a little bit too much, but it's okay. It'll be fine. Don't even worry about it. So if I kind of do like this kind of thing, and then I can press the button there. It's not sliding. No, it's the glue seems to be holding pretty well. Seems good. Okay. Plug this in, no button pressed. Yay! It opened Notepad, it typed hello world. Okay, so it ran the payload. Now I unplug it, I press the button, plug it in, the LED is blinking, and it does not run the payload. And I feel like that LED is like pretty visible. Like that's easy to see through the case. So I think I'm pretty happy with how that turned out. With like the transparent PLA, I think that worked out pretty well.